Hello guys, let's begin with the first chapter, Matter in Our Surroundings, in this video lecture series. A brief outline of this chapter is given here. First we will look into some introduction of this chapter. Then we will go on to the physical nature of matter, characteristics of particles of matter. We will look what are the states of matter and try to answer, can matter change its state? And in the end, we will end the chapter with the topic evaporation. So let's begin with the chapter. Our surroundings has a variety of things with different shapes, sizes and textures. Everything in this universe is made up of material which scientists have named matter. We also see as we look around that all the things occupy space, that is, volume, and it has mass. Modern day scientists have evolved two types of classification of matter based on their physical properties and chemical nature. In this chapter, we will see the physical classification of matter, its properties, the state in which it is present, and try to answer if matter can change states or not. So the first topic of this chapter is physical nature of matter. Matter is made up of particles. When salt or sugar is dissolved in water, it uniformly spreads throughout the water. These particles are very small. To prove this, we add a small amount of potassium permanganate in 100 ml of water. The color of water becomes pink. Now we take 10 ml of this water and add it to 90 ml of clean water. The color obtained now is fainter. Now we repeat this process and we see that the color becomes fainter and fainter. This means that the potassium permanganate particles were uniformly spread throughout the water. Moving forward, let's see the characteristics of particles of matter. Particles of matter have space between them. And how do we prove it? When salt or sugar is dissolved in water, particles of these get accommodated in the spaces present between the other particles. This shows that there is space between particles of matter. Particles of matter are continuously moving. Particles possess kinetic energy, which is the energy that is associated with the movement of an object. Higher the temperature, higher is the kinetic energy as the speed of the object is higher at higher temperature. Particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. Particles of matter attract each other. The particles of matter have force acting between them which keeps them together. The strength of this force of attraction varies from one kind of matter to another. Having seen the characteristics of properties of matter, now let's look at the states of matter. There are 5 states of matter. They are the solid state, the liquid state, the gaseous state, and there are 2 other states that will not be covered in this chapter. Those are the Bose-Einstein condensate and the plasma. So let's first see the solid state. These have definite shape, distinct boundaries, and fixed volumes. That is, they have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break down under force, but it is difficult to change their shape, so they are rigid. The second one is the liquid state. Liquids have no fixed shape, but have fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but called fluid. Solids, liquids, and gases can diffuse in liquid. The rate of diffusion of liquid is more than that of solid because particles in liquid are loosely bounded and move freely and have greater space between each other. The third one is the gaseous state. Gases are highly compressible as compared to solids and liquids. The LPG cylinders that we use in our home or the liquefied petroleum gas is compressed gas to such an extent that it gets converted into liquid, as suggested by its name, liquefied petroleum gas. Similarly, we also have CNG, that is the compressed natural gas, which is used in automobiles and also in industries. Due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. In the gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. The picture here shows how the particles are arranged in solid, liquid, and gas. In solids, the particles are very densely packed. Hence their movement is very restricted. In liquids, the movement is little bit free as the force of attraction between these particles is little less compared to solids. But in gas, this force of attraction is very less and hence the particles can move easily. And hence these particles are very loosely bound to each other. Now the question arises, can matter change its state? We all know water exists in three different states, that is ice, liquid water and water vapor. Thus a matter can exist in more than one form and hence can change its state. Now we need to know what is the effect of change of temperature on the state. On increasing the temperature of solids, the kinetic energy of particles increase. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the force of attraction between the particles. The particles leave their fixed positions and start moving more freely. A stage is reached when the solid melts and is converted to a liquid. The temperature at which a solid melts to become a liquid at atmospheric pressure is called its melting point. The melting point of ice is 273.16 Kelvin, that is also 0 degree centigrade. The process of melting, that is the change of solid state into liquid, is also known as the fusion. The solid state upon heating produces the liquid state, which again on heating produces gaseous state. On cooling the gaseous state, we get the liquid state, and on cooling the liquid state, we get the solid state. Now when a solid melts, its temperature remains constant, so where does this heat energy go? We need to answer this question with an experimental setup. In this experimental setup, we take a beaker which is filled with ice and a glass stirrer is kept to stir the ice. A thermometer is placed inside the beaker to check the temperature. Now the burner is heated and the ice starts to melt. The heat gets used up in changing the state by overcoming the forces of attraction between the particles. As the heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So, particles in water at 0 degree centigrade or 273 degree Kelvin have more energy as compared to the particles in ice at the same temperature, as they have the additional energy of latent heat. So this energy, which does not produce any change in temperature, is also known as the latent heat. Now when we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling is a bulk phenomena. Particles from the bulk of liquid gain enough energy to change into vapor state. For water, this temperature is 373 Kelvin or 100 degrees centigrade. Water vapor at 373 Kelvin have more energy than water at the same temperature. This is because the particles in the steam have absorbed extra energy in the form of latent heat of vaporization. Some matter directly change from solid state to gaseous state without changing into the liquid state. Example is the naphthalene balls that is used in home. We see that these balls disappear after some days. This is because it changes its state directly from the solid state to the gaseous state, and this change is also known as sublimation. Now, effect of change of pressure. We had earlier seen the effect of change of temperature on the states of matter. Change in pressure too can change the state of matter. Applying pressure and reducing temperature can liquefy gases. Increasing the pressure brings the particles of matter close together, increasing the force of attraction between them and causing change in state. Solid carbon dioxide, also known as dry ice, which is kept under a very high pressure, directly converts from solid state to gaseous state without changing into the liquid, and hence the name. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid, or gas. This brings us to the last topic of this chapter, evaporation. Water, when left uncovered, slowly changes into vapor. Wet clothes dry up. What happens to water in above two examples? We know that particles of matter are always moving and are never at rest. At a given temperature in any gas, liquid, or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. This phenomena of change of liquid into vapors at any temperature below its boiling point, this thing is important, below its boiling point, is called evaporation. Now let's see some factors that affects evaporation. An increase in surface area increases evaporation. If the surface area is increased, the rate of evaporation increases because more number of particles near the surface of the water will be able to evaporate easily into vapor form. An increase in temperature also increases evaporation. This is because more number of particles will have enough kinetic energy to convert into vapor state. A decrease in humidity also increases evaporation. Humidity is the amount of water vapor that is present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. Hence, a decrease of humidity increases evaporation. An increase in wind speed also increases evaporation. It is a common observation that clothes dry faster on a windy day compared to a normal day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings, and hence the increase in the evaporation. Now, how does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cool. Wearing cotton clothes in summer helps in proper evaporation of sweat released from body, keeping the body cool. Similarly, opposite to the phenomena of evaporation is the phenomena of condensation. In condensation, vapor converts into liquid. When a tumbler with ice in it is kept in open atmosphere, water droplets start appearing on the outer walls of the tumbler. This happens because the water vapor present in the air gets condensed on the outer surface of the tumbler due to its low temperature. With this, we come to the end of the first chapter, Matter in Our Surroundings. Thank you.